Hello students, welcome to another session on the software testing. Students, in last lecture we discussed about quality control and quality assurance. We have seen the difference between the quality assurance and quality control. Quickly we will recapitulate it first and then we will move on. So, quality assurance is nothing but it is more towards about the process. So we are concentrating about the process through which particular product is going to get manufactured. So that is about the quality assurance. So we are trying to assure the quality of a product. So we will work on the process. We will keep our process foolproof. We will keep working on the process so that whatever will come out through that process will always be of a good quality. So that is nothing but a quality assurance process. To that, another point that we discussed, quality control. Quality control is nothing but validating it. So whether after going through all this quality assurance process, whatever the product that we have obtained at the end, whether it is of a good quality or not, that we will evaluate in the quality control. So quality control is coming after the quality assurance that we have seen. We took couple of examples for that. Okay, we will again take one small example and then we will move on. So let's consider a car manufacturing unit. So in the car manufacturing unit, how quality assurance will be done? So in the car manufacturing unit, quality assurance will be done through the process. So they will assure that which particular type of steel that they are using, how they are manufacturing the car, which type of chassis they are using, okay, what standards they are going to adopt, okay, in the workmanship, how they will ensure that the defect will not be forwarded, it will be captured in the next phase or in the same phase. So that is nothing but a quality assurance. They will maintain their chain in such a way so that the product or the car which is going through that all the phases will be of a good quality. There won't be any defect in the car. So that is nothing but the quality assurance. And in the quality control, what we will do? In the quality control, the person or the team of the quality control will take the car in their hand and then they will measure it against some predefined standards, that whether the steering is right, whether the steering play, how much steering play should be there, that whether it is right, acceleration is good, braking is correct. Whatever the predefined figures are there, they will compare the performance of that car with that predefined figures. And if it is okay with that, then only they will pass on that car and they will say it is now done and it is now of a good quality. So now they can pass it on to the customer. So what they have done in the quality control, they checked it, they tested it. Okay, so that is nothing but a quality control. And if they found any problem in the car, then they would refuse it. Okay, then they will ask that car to go back again and then they will make it again clear. It will again come through all the process and again they will test the car. You may have a question now, whether both of these things are essential. Are we not actually wasting our resources in putting up two different things like in quality assurance and quality control? So the answer of the question is that both things are complementary to each other. We cannot reject one thing from the other. Let's say suppose you have a quality assurance team in place. Okay, but quality assurance team cannot actually work without the feedback of quality control. Because quality control is actually observing the quality of a product that is coming out through that process. Okay, so what quality control will do, they will give the feedback to the quality assurance team. If the quality is not proper, so quality control team has to give the feedback to the quality assurance team that something is going wrong in the process and because of that we are not getting the product that we are expecting, or the quality of the product is not that good, isn't it? So both things are essential. Let's say suppose we have a quality control in place and we don't have a quality assurance. Again, this is not okay. The reason because in the quality control we will only test the end product. And once we have tested the end product and if we found that the product is bad, what we will do? We will reject it, we will refuse it, or we will send it back in the process, isn't it? But how we will minimize the defect rate? Okay, after manufacturing 100 units, if the 70 to 80 units are defective, then certainly we have to work on the process. So for that purpose, we need quality assurance also. So both this quality control and quality assurance, both these things are complementary to each other. Okay, they are not substitute to each other. We cannot have a quality control without a quality assurance, or quality assurance without a quality control. We cannot have something like that. We need both in their place, and they should work in their way. Alright. So today we will discuss another concept, and that is the verification. Now verification means I have to verify the product against some set standards. So that is the verification. Okay, so probably I have some set of standards which are given in my company, which have been followed in company, how the software should be developed, which phases should be used, how I will transform from one phase to another phase, okay, which people should be involved in the working. All these are nothing but a set of policies. Okay, so I have to check whether I am following that all policies or not. So that is a verification. So there is a sentence, are we building the product right? Means the way that we have chosen to develop the product, whether is it right or wrong, that we have to check in the verification. Okay, so in the verification, the software should conform to its specification. So here our attitude will be to check the software to the set standards. Okay, there might be some international policies that you are using, or probably you will have some policies from your company. Okay, in order to develop a correct product, you might have certain policies in place in your company. So you are verifying that against your product. So whether these policies, this set of rules are being followed in product development or not, that you are checking in the verification. Now, opposite to that, or we can say complementary to that, there is a validation. In the software validation, what we do, are we building the right product? So the product that at all I am developing, whether it is right, okay, whether it is actually right in terms of user's perspective, that we are going to check in the validation. Now both things are different. In the verification, we are verifying it against the company's policies. We are verifying it against a set of standards which our company used to follow for the development. Okay, in the verification, I am not more inclined towards the user's expectations. Okay, that is a verification. So once the product is in hand, once the product is in the company or in the shop floor, what we do in the verification, we will simply verify it against the set of standards which are given in our policies. We will not think in terms of user's way in the verification, but in the validation, now our attitude will change. The way of looking at the software will change, and in that what we will do, we will test our software in user's perspective. So what users wanted to have from our software, and whether whatever the software that we are developing, whether it is really satisfying the expectations of our customer, that we will check in the validation. So in the validation, are we building the right product? Means maybe I am going to follow all the set of standards which are set in my company. So in verification, I will be okay. But if at all the software is not fulfilling the expectations of the customer, then it will fail in the validation. So that is the verification and validation process. We will take one example to explain this in detail. Let's consider there is a builder and then there is a customer. Customer comes to the builder and he asks for a flat. Okay, now customer has certain requirements. So that customer is now telling some of the requirements to the builder, that he wanted to have a flat of a 3-bedroom plus hall and kitchen. He wanted to have a balcony. He wanted to have a big terrace. He wanted to have suppose 2 bedrooms attached with toilet and bathroom. All these are nothing but the requirements which have been specified by the customer. Okay, he has also mentioned, customer has also mentioned that the dimension of the hall, how much dimension of the hall should be, how much dimension of a kitchen should be. So he has specified all his requirements. Now builder has taken out all these requirements, he has written it, okay, and he has put forward all these things to the actual person who is going to perform the further tasks like perform the modeling, who will design the entire flat system. Okay, so structural engineer or the architect, he has put forward entire thing to the architect. Architect accordingly took some of the requirements or all the requirements he has understood according to his perceptions, and then he started performing the further task of designing. He designed it, then further he has also asked the mason who is actually working on the actual project to start with the design. Okay, whatever the design he has given, according to start implementation. Okay, now here in this case, what the verification task will do? In the verification, we will ensure that all the requirements from the customers are being given to the architect, whether architect has done with the proper drawing, whether drawing is correct. If the drawing is correct, then whether the structurally it is feasible. Okay, the structural engineer will check the feasibility with the structure. Then structural engineer will check the quality with the actual product, like the concrete, like the cement, like the sand, whether it is according to the predefined standards. So this is nothing but a verification process. So throughout the project, we will keep on verifying the things against the set standards. So it might be that builder has a certain set of standards, isn't it? So the strength of the cement should be this, strength of the concrete should be like this. So we will keep on verifying this till the product reaches to the end of its cycle. Now this is all about the verification. And the validation, what we will do, actually we will see the product and we will compare that according to the customer's expectations. Now what customer has stated to the builder, accordingly we will check the product. So what the customer has stated, that he wanted to have a 3 BHK. So whether it is 3 BHK, that we will check. Now customer has told that the dimension of hall should be like this. Whether it is actually into that dimension, that we will check. Now whether the 3 BHK or a terrace he wanted to have, whether the terrace is there, that we will check. The dimension of terrace, if it is stated by the customer, that we will check. So that is nothing but we are validating it. But in the validation, we are thinking in terms of customer's expectations. What customer has stated. Probably my verification would have done properly. Okay, in the verification, whatever the set of standards are there from the builder's side, that might have been followed. But let's say suppose the dimension of hall is less than the expected dimensions. In that case, it has failed in the validation, isn't it? Because what customer wanted to have, customer exactly wanted to have a dimension, he has stated in that way he wanted to have an hall or drawing room. But it is not like that. So it has failed in the validation, but it has successfully passed through the verification. Because in the verification, we compare that with the policies, the strength of the material, then the quality of the design, that we tested. And that was actually okay with the set of standards. But in the validation, it was failed. So that's why verification and validation both are essential. In the verification, we compare that with a set of standards, okay, to conform to its specification. And the validation, whether the product is really developed according to the user's requirement, whether it is actually fulfilling the user's requirement, that we will check in the validation. So both verification and validation must be applied at each stage in the software process. So here, while we are developing the software, both things are essential. You should verify it and also validate it. In the verification, you will test it, you will verify it against the set of standards, whereas in the validation, you will test whether the customer's requirements are taken into consideration and whether those requirements are getting fulfilled in the development or not. That you will check in the validation. So both are essential. So here we have two principal objectives. Discovery of defects in the system. So obviously as a tester we wanted to understand the defects. We wanted to find out the defects in the system, and assessment of whether the system is usable in an operational situation. And in the validation, the second part, that whether the system is actually useful, that we wanted to check. So that is the validation. Now we will see another concept, that is static and the dynamic testing. So static means something which is not dynamic, means something which is not executing. Okay, so static testing means you have to test the software without executing it. Now how you will test a software without executing it? So here we are concerned about the software documentation. We are concerned about the software diagrams which has been drawn, design, flow charts. We are more concerned about the finding out the faults in those parts of the software. So even though the software is not in place, or even though the software is not running in front of you, still you can actually test your software through the software inspections. Okay, so you will ask for the documentation, whether documentations are done properly or not. If you could figure out the bugs in the documentation, you can figure it out there. Then you will ask for the diagrams like a data flow diagram, then flow charts, then different sorts of diagrams, class diagrams, object diagrams. You will ask for all these diagrams and you will go through all it. And if you could figure out the problems within those things, then you can figure it out and you will call it as a bug in that place. So it is a static testing, to which we generally call it as an inspection. Okay, because we are inspecting it. We are not actually testing it at the end. Okay, so that is called as a software inspection. So that is done statically. Statically in the sense without executing. So without executing in the sense, you are just testing the documentation. You are testing the code also sometimes, but without executing it. So you are looking at the code and you will only see, you will have a dry run of the code if you want. Otherwise, you can have the, you will see the guidelines are followed or not while writing down the code, whether the code is properly commented or not. That you will check in the static testing. Then we have a dynamic testing. In the dynamic testing, we will actually put the software, we will run the software into the computer and then we will see how that software will behave. So in the dynamic testing, you will give the input to your software. Software is running in front of you. It is doing the processing and you will see the output. You will check the output with the expected outcome that you have already figured out. You will match it and if it is okay, then all fine. Otherwise, you will put it as a bug. So that is a dynamic testing. So in the dynamic testing, the software is in the execution and then you are testing it. So that is a dynamic testing. This diagram will explain you the difference between the static and the dynamic. So here we have a static verification. Okay, so always understand when you are doing the verification, it is more towards a static testing. So here what we generally do, we have the inspection. So we will get the requirement specification in our hand. We will check whether the requirements have been gathered properly. Do you have any defects? Do you have any discrepancies which you can find out in the software specification or the requirements that you will figure out? Then you will check the high level design. Whatever the design has been drawn, you will ask for the different diagrams that you will check. That is under the static verification. You are verifying it because already there are a set of standards which are given in your policies in the software development and that you are simply following it, isn't it? So that is a verification and it is static. Okay. So then you will have a formal specification. Okay. After having the proper requirement gathering, you will have the formal specification. Then you will have a detailed design and then you will have a program. See, program is coming after the doing all these processes. So program is coming at the end. You don't have a program at the beginning, isn't it? So in the program, we can actually have a static verification also, as well as we can have a dynamic validation also, because that is the only thing which you can execute, isn't it? These things like a requirement specification, high level design, formal specification and detailed design, that you cannot execute, isn't it? So there you have a static verification. Okay, and once you will have the program in your hand, it is now dynamic, so you can execute it, and it's a validation also. Validation in the sense, now you can give the input to your program and you can check the output is correct or not. So you can test your software in the user's perspective also. So that's why it is validation. Okay, so don't confuse over the static and dynamic. When we are talking about the static, it is like a verification only, because we cannot execute it, because what static says you don't have to execute it, and the verification you are simply comparing the things with the set of policies. So you have a set of policies to which you are comparing the outcomes of these things like a requirement specification, high level design and all. But once you will have a program in your hand, you can do the static verification also and you can do the dynamic validation also. How you will do the static verification? So in that you will have the program, you will not execute it, in the static verification, you will just go through the program and you will try to figure out the errors having the dry run of that program. Means without executing it, you are not using the compiler, but you are simply finding out whether the program guidelines are being followed or not, whether the variable names which are used, they are correct according to the guidelines or not. That you will check whether proper indentation is done in the program or not, proper commenting is given in the program or not. That only you will check in the static verification. And once that is done, then you will have a dynamic validation. So in the dynamic validation, actually you will put the program into the compiler, you will compile it and you will run it. And once the code is in the running, then you can actually put the input of the user's input, and then you will check the output of the product. Okay, that is the validation, because what user wanted to have, let's say you have a calculator. Okay, in the calculator you will give the input like a 1 plus 1 and you will check whether 2 is the output or not. So here it is a validation also, because what our customer wanted to have, customer's requirement is addition should be done. So you are now comparing whether addition is done or not. So it is validation also. Okay, and most of these things are contributing to the prototype if it is at all required. If in your software requirements, if the prototype is required, or if the customer is willing to have the prototype without having the direct product in hand directly, so you can have these things as an contribution or as an input to the prototype also. So that is nothing but the static and dynamic verification and validation. Hope you have understood this properly. With that, we have come to an end of this session. We'll meet you again in another session. Till then, keep studying. Thank you.